In this video, I'm going to talk about the composition of two functions. So the notation that we're going to use is f circle g, and this is just a little bitty circle. It's not like an O or a 0 or anything. It's just kind of midway vertically speaking. So f circle g of x, and that's the notation we're going to use. But what is it really? It's just saying that f of g of x. So we're going to take the g function, whatever it is, and put that in for f. Conversely, we have g circle f of x, and that's going to be when you put the f function into g. In the first example, we have two functions, f of x and g of x, and f of x is going to be defined as 3x plus 5, and g of x is going to be defined as 2x minus 7. So if we're going to find f circle g of x, this means that we're going to put the g function into the f function. So let's see what that looks like. So if we have the g function here, we have 2x minus 7. So everywhere we see an x in our f function, we're going to put this 2x minus 7. So the g, 2x minus 7, goes into the x right there. So it's going to be, I like to do it this way, that our f function kind of looks like this. 3 times a number or a quantity or an expression or something, and then plus 5. So what is it that we're substituting in for x? We're substituting 2x minus 7, which was our g function. So then we can just simplify it. We have 6x minus 21 plus 5. So it's going to be 6x, minus 16. And that's going to be our f circle g. We can also go the other way around and find g circle f of x, which is going to be putting the f function into the g function. So if we look back up here real quick, our g function is going to be the 2x minus 7. So I have 2 and then our x and then minus 7. So I'm going to put something in for the x. And what am I putting in for the x? Well, I'm putting the f function, 3x plus 5. 3x plus 5. So when I go ahead and distribute that, I'm going to get 6x plus 10 minus 7. So to simplify it, it should be 6x plus 3. So with these two functions, f and g, I found the composition of both of them. F circle g is going to be 6x minus 16, and g circle f is going to be 6x plus 3. In this second example, I'm going to have two more functions, f and g, and f of x is going to be defined as the square root of x minus 3, and g of x is going to be just x plus 3. So when I do the first composition, I'm going to look at f circle g of x, which remember that means putting g into f, so it's f of g of x. So what that looks like now, I'm going to put this g function into f. Well, f is going to be this big guy. He's going to be the square root of my x, or some quantity that's going to be substituted in for x, minus 3. So what is that quantity that we're substituting in? Well, it's going to be x plus 3. So when I look at this now, without the parentheses, it's x plus 3 minus 3. And the plus 3 and the minus 3 are both inside the square root together, so they actually cancel one another out. So what I'm left with is just the square root of x. So the first composition, f circle g of x, is just going to be the square root of x given these two functions. If I go ahead and do the other one, g circle f of x, which means I'm putting the function f of x into the function g, well, my g function is my x plus 3, so it's going to be something plus 3. And what is that something going to be? What quantity? Well, it's going to be the f of x, so it's going to be the square root of x minus 3. Okay, so whenever I take these parentheses away, I have the square root of x minus 3 and then plus 3. Notice now that the x minus 3 is the radicand. He's underneath the square root here, and the plus 3 is outside. So in this case, I can't cancel them, and there's nothing else I can do to simplify that expression. So that's the answer, g circle f, given the two functions that we looked at first. In this third example, we have two more functions, f of x is going to be defined as x squared minus 3, and g of x is going to be defined as x plus 2. So we're going to do the composition both ways again. So the first one is f circled g of x, which again is putting g into f. So the f function is going to be outlined as some quantity squared minus 3. So when we plug g of x in there, we're going to plug in x plus 2. So we're going to have the quantity x plus 2 squared and minus 3. So lots of textbooks and teachers love to give you problems like this, because just because this is x squared doesn't mean you don't have to do anything to it. You can just call it x squared. Well, once you substitute something in there like a quantity, x plus 2, quantity squared, remember we're going to have to multiply this out. In this case we can use FOIL like that. So we have x squared and then plus 2x and then plus another 2x plus 4 minus 3. So like terms are here and here, they can go together. So we'll have x squared plus 4x plus 1. And that will actually be the solution then once we simplify here, f circled g. So make sure when you're squaring this quantity that you actually put the quantities next to each other and you FOIL them out or multiply them out somehow. So the other one's going to be g circle f of x, which looks like g of f of x. So when we do that, we have g as our big function here, so x plus 2. So we have some function or some quantity or some value or whatever, our x value right here, and then plus 2. So what is that value going to be? It's going to be x squared minus 3 because it's our f function. So we're going to put x squared minus 3 in there. When we simplify, it'll be x squared minus 3 plus 2, which those are like terms, so it'll be x squared minus 1. So we can find the composition of those functions as well, and g circle f of x is going to give us x squared minus 1. And f circle g of x is going to give us x squared plus 4x plus 1 for these two functions, f and g. In this fourth and final example, I have two functions. F of x equals the square root here, this quantity x minus 4, and g of x is going to be x squared plus 2. So whenever I find the composition, this f circle g of x, it's going to be f of g of x. So I'm going to put the g function again into f. So my f function is going to be the square root of x minus 4. And again, I'm going to put this big quantity here because I'm not sure what x is going to be when I substitute it in. In this case, it's going to be g of x, which is going to be x squared plus 2. So whenever I do that, then I have the square root of this quantity, x squared plus 2 minus 4, which then those two go together, and I get the square root of x squared minus 2 when I simplify all that stuff. So my f circled g in this case, or my f of g of x, is going to be the square root of this quantity, x squared minus 2. Well, I can do the other one now. I can do g of f of x, which is going to be given by g circle f of x. And that means we're going to put f into g. So g is my big guy here. He's going to be my x squared plus 2. So it's going to be some quantity squared plus 2. So what is my quantity here? I'm going to put f in there. So it's going to be the square root of this quantity, x minus 4. Okay, so you see here, and teachers love to do these problems, because this squared out here and this square root actually cancel one another out, because when you square a square root, you actually just get the radicand by itself. So it'll be x minus 4, and then plus 2. So those go together, so it'll be x minus 2. So there's that interesting relationship here. The last one was the square root of x squared minus 2, and this one's just going to be x minus 2 whenever you do the composition of these two functions.